We often hear the terms immutable and immutability. What do they mean? And as developers, why should we care? Immutable basically means something that cannot be changed. In programming, immutable is used to describe a value that cannot be changed after it's been set. But most programs require creating, updating, and deleting data. So why would we ever want to work with data that can't be changed? In this video, we look at immutability of primitives, arrays, and objects with JavaScript examples, and we enumerate why immutability is important for programming. Let's start with primitives. In JavaScript, primitives, like strings and numbers, are immutable by default. This means that once a primitive value is created, it cannot be changed. Wait a minute. I change primitive variable values all the time. Well, it might seem like we're modifying a value, but that's not actually the case. Here's an example. It looks like we're changing the string greet, but JavaScript does not change the string. Rather, it creates a new string. Let's look at an illustration. The code creates the string hello and assigns it to the greet variable. The append creates a new hello world string and assigns it to the greet variable. The original hello string is not modified since JavaScript strings are immutable. Rather, a new hello world string is created, so the string value is immutable, but the greet variable is modified to the new string. Here's another example with numbers. The code creates the number 42 and assigns it to the total variable. When we change the number, the code creates a new number and the variable total is reassigned to this new value. The original value remains unchanged. So primitives are immutable by default in JavaScript. Let's look at arrays. In JavaScript, arrays are mutable by default. This means that the array can be altered after the array is created. We can modify it in place, adding, removing, or changing elements. In this example, we define an array. When a variable is assigned to that array, the variable doesn't store the array. It stores the memory address where the array resides. The push method modifies the original array, in this case adding 8 to the end. Notice that the memory address of the array doesn't change, but the array itself does change, so the array value is mutable. This mutability provides flexibility, but mutability can lead to unintended side effects, especially in larger applications or those involving concurrent operations. There is also another issue here. Say you have code in a setter that should execute when the array is changed. Or you're working with a framework, such as Angular, that provides change detection. Or you're using a state library, such as Redux, that requires immutability. As we saw in this example, our array is changed, but our ages variable didn't actually change, since it's referencing the memory address. So the setter or change detection or state management might not see that the array was changed. To avoid these pitfalls of mutability, we, as JavaScript developers, often use patterns or methods that do not alter the original array, but instead return a new array, thereby embracing immutability. In this example, we start with the same array, but when we add an element, we use the JavaScript spread operator. The spread operator makes a copy of the existing array at a new address by spreading the existing array. We then add the new element to that copy and reassign the ages variable to the address of the new array. Notice that the original array is not changed. By using the spread operator, we achieve immutability. In addition to the spread operator, many of the array methods also create a new array, and therefore treat an array as immutable. Other array methods modify the array in place and are therefore mutable. Here are some examples. Map creates a new array from an existing array, mapping each element using a function we provide. It leaves the original array unchanged, so it supports immutability. Push modifies the original array in place, mutating the array. Filter creates a new array with items matching the defined criteria. It leaves the original array unchanged. Sort sorts the array in place, thereby mutating the array. Slice creates a new array from a portion of an existing array. Here we copy the original array elements starting at index 1 through index 3 to a new array. Splice changes the contents of an array in place, adding, removing, or replacing existing elements. In this example, the code starts replacing elements at index 2, replaces one element, and replaces the element with 18. So, even though by default arrays are mutable, we can use immutability techniques to better manage our arrays. What about objects? Objects in JavaScript are also mutable by default. We can add or delete properties and change property values in place after an object is created. In this example, we declare a person object. When a variable is assigned to that object, the variable doesn't store the object, but rather a memory address where the object resides. This code then modifies the value of an object property, changing the age. This modification directly alters the original person object. Notice that the memory address of the object doesn't change, but the object itself changes. This is similar to array mutability, and that makes sense because arrays in JavaScript are basically objects. Mutability provides flexibility, but can lead to complex bugs if not carefully managed. And as with an array, there's another issue here. Say you have code in a setter that should execute when the object changes, or you're working with a framework such as Angular that provides change detection, or you're using a state management library such as Redux that requires immutability. In this example, our object changed, but our p variable didn't actually change since it's referencing the memory address. So the setter or change detection or state management may not see that the object was changed. It's often better to handle objects in an immutable manner. JavaScript provides features to aid with immutable objects. In this example, we start with the same object, but instead of changing an object's property value directly, we create a new object at a new address. Then we update the property in that new object. We again use the spread operator, which makes a copy of the object by spreading it into the new object, and reassign the p variable to the address of the new object. Notice that the original object is not changed. By using the spread operator, we achieve immutability. So we've seen how primitives are immutable by default, and that arrays and objects are mutable, but we can work with them in an immutable way. Why is that important? There are several reasons that immutability is important to our everyday coding. Once an immutable value is set, it isn't changed. Rather, a new value is created. This makes the value predictable and consistent throughout the code, so it aids in managing state throughout the application. Plus, immutability is a key principle in state management frameworks, such as Redux. Code becomes simpler and less error-prone when data structures don't change unexpectedly. This also simplifies debugging and maintenance. Embracing immutability is in line with functional programming principles, leading to fewer side effects and more predictable code. Immutability is a fundamental concept in programming. An immutable value is a value that cannot be changed after it's been created. This concept is important to functional programming and state management. It's a valuable concept, especially when dealing with concurrency in large, complex code bases. While JavaScript objects and arrays are mutable by default, adopting an immutable approach to handling them can lead to cleaner, more reliable, and easier to maintain code. Thanks for watching, and if this video was useful, please like and subscribe.